In this demonstration, you'll learn about ANSYS AIM reference frames. You will learn what a reference frame is, how to define cylindrical boundary conditions relative to a reference frame, how to create a reference frame based off your geometry, and how to define a reference frame relative to another. Coordinates, vectors, velocities, and all other spatial quantities in AIM are interpreted relative to a specific frame of reference. By default, this is the global reference frame. For example, the position of a point on our inlet relative to the global frame is given by a vector with Cartesian vector components defined as the offset to this point in the x, y, and z direction of the global frame. If we introduce a new reference frame, the position vector relative to this frame will be different, but the point hasn't moved, only the frame relative to which we measure it. In general, a reference frame provides a local set of coordinates relative to which you can define or measure things such as the position of a body, a force at a boundary, or the velocity at an inlet. One way of defining your frame of reference is to use your geometry. In this first example, we have a T-junction where we want to define swirl at the inlet using cylindrical velocity components for convenience. Instead of defining the velocity magnitude in the direction normal to the boundary, we want to define it using directional components. However, the cylindrical components are defined about the z-axis, and by default our boundary condition is defined relative to the global reference frame. What we need is a frame aligned with this inlet. So the solution is quite simple. Let's put in our velocity components. Since it is relative to our global reference frame, it probably isn't aligned with our inlet. To make the reference frame aligned with our inlet, simply select Create New from the Relative To option. This gives us a new reference frame located at the centroid of the face and with the z-axis pointing normal to the face. We want the z-axis to point in the reverse direction. Now we have the frame where we want it, and we can solve this in which we will get that nice sort of swirl. You can define additional reference frames, each having a unique location and orientation. If we create a new reference frame, what we will get is a frame initially located on our global frame. We've hidden the faces to see it a little better. When we create a new frame, we typically want it somewhere else in space. The way you define your frame allows for a lot of flexibility. We can enter the coordinates of the reference frame's origin such that it is offset from the global frame in the y direction. I can offset it in any direction I want, and I can also have the axes pointing in a different direction. The other way we can define a reference frame is to pick off some location. Here we have some vertices. So I can pick a vertex in the geometry and locate the frame on that vertex. Or similar to what we did earlier, we can pick a face or even an edge and then locate it at the centroid. AIM automatically orients the other axes, but these may not end up where we want them. So we want to define the direction of our axes. We can define the x-axis in our frame to point in the y direction relative to the global reference frame. You can also pick a location that our axis points to, such as this cylinder, or you can choose any arbitrary point to serve as the direction of your axis by selecting Hit Point. However, for this example, we want the z-axis to be defined by direction and to point normal to the face of our inlet. We can then reverse the direction of the normal to point inwards. Now that we've created a frame, we can modify it further by translating and rotating it. We can drag the z-axis, and this adds a translation. Similarly, we can grab one of those circles and rotate the frame. You can also add rotations and translations manually. If you delete the transformations, it will take you back to your base definition. We can define these transformations relative to our local axis or the parent frame's axes. The parent frame is the frame relative to which we defined our new frame. Transformations relative to the local axes are done relative to the frame's current position and orientation, like so. If you rotate relative to the parent, the rotation will be about the parent frame's axis. If we had defined our frame relative to a different frame, the transformation would be relative to that one. If we pick a different parent frame, our frame's definition will stay the same, but it will move to a position relative to its new parent. And if the parent frame is modified, the frame will update accordingly, always maintaining the same relative position. And finally, here's a summary of all the reference frames that we've created and how they relate to one another. This concludes our demonstration of ANSYS AIM reference frames.